we're going to start notes 8.6, and this is just a continuation of notes 8.5. Your warm-up is exactly what we did on notes 8.5, so I want you to try that warm-up on your own, okay? But remember, who is your best friend? Desmos, right? Use Desmos. Let it help you. Let it check your answers. You are going to get to use that on the STAR test, so definitely use it on your notes. We need to get good at that. We need to practice. So on this, you're just going to look at this function right here. Remember, all functions start at f of x is equal to x squared, and your vertex is always at 0, 0. That's where we start. And then you are going to see what this did. And if you remember from our last notes, last notes, if it's inside of the parentheses, it's horizontal and it lies. If it's outside of the parentheses, it's vertical and it tells the truth. So try that warm up on your own. Now today's notes are a little bit shorter, but we're going to kind of just go through the rules here and you're going to kind of see what happens. So if you'll take a look, this time, instead of talking about a horizontal or a vertical shift, we're actually going to talk about stretches and shrinks, as you can kind of see on our rules here. So a vertical stretch is when A is greater than 1. So that's a vertical stretch. And you can kind of see how it's going from here, right? This is our original, that red line, sorry. And then it does a vertical stretch this way, right? So if A is greater than 1, it is a vertical stretch, okay? Now, a vertical shrink, let me use a different color, is when A is between 0 and 1. So, like for example, 1/4. That's a vertical shrink. Now, that sounds kind of confusing, but when you take a look at our examples here, what's kind of happening to that line? Think about when it stretches. A vertical stretch is where it goes up higher, right? A vertical shrink is where we're going like this, okay? So I know that's kind of funny, but remember, Desmos is your best friend. So like on this first one, a vertical stretch could be something like 4 and I lost what I was doing. X squared. And then kind of see what happened there. Take a look. It's a vertical stretch, right? Now let's try a vertical shrink. So instead of that one, let's try 1/4. 1/4. Let me find my functions here. 1/4. Okay. And then I need to make sure I come out to the side. You notice how it went from that bottom 4 over to here? Make sure you do that or you are not going to get the right answer. Oh, I didn't mean to do that. So, move that out of my way. 1/4 x squared. Take a look at what happened there. Look at how that graph changed. So remember, Desmos is your best friend. Make sure you're following that, okay? Now, when you get a vertical stretch or a vertical shrink, look at where that number is. Take a look here, the beginning, okay? And then again at that beginning. So, let's take a look at a horizontal. One more time, remember, for a vertical, your A, let me use a different color, sorry. A is in front of that f of x, or that x squared, right? And that's how you know it's going to be vertical. I, again, meant to use a different color, but there you go. Now, horizontal, where is your B? Take a look. Where is that B at? Inside the parentheses. So remember, on our last set of notes, we said inside the parentheses is horizontal. Same thing here. Inside the parentheses is horizontal. But now it's a horizontal shrink and a horizontal stretch instead of a shift. So if B, that number inside of the parentheses, is greater than 1, it's a shrink. So see, that's a little bit different because with the vertical, if the A is greater than 1, it was a stretch. But with horizontal, if B is greater than 1, it's a shrink. Okay? Okay, so remember, inside the parentheses and tells a lie, just like last time, right? That is the same thing. Inside the parentheses, it's horizontal, it tells a lie. Outside of the parentheses, it is vertical and tells the truth. So a horizontal stretch is when B, I gotta find another color here, let's do purple, is when B is in between 0 and 1. So like, for example, inside the parentheses is 1/4, inside the parentheses is 2. And again, if you want to see what these look like, you can test them out in Desmo. So like on this one, I'm going to do exactly that. I'm going to say parentheses 2x close parentheses squared. And there you go. That's what that would look like. That's what a horizontal shrink looks like. Let's take a look at what a horizontal stretch would look like. So we're going to do inside the parentheses 1/4, and then make sure you go over to the side, x close parentheses squared, and there you go. There's a horizontal stretch. See how we kind of got fatter that way. All right, take a look at one more. This is a new rule. Okay, so on that next page, here's a new rule. A reflection. A reflection is, as you can see, so look here, our original was going this way, right? It's our U. Well, now a reflection caused it to flip, reflect the other way, okay? When you get a reflection, that is when a negative is outside of the function. And again, we can test that out. So like that right there, we can put negative x squared, and there you go. There is a function reflection. Okay, now these notes are a little bit different because instead of doing some of these together, you are actually going to do each of these on your own by following those rules. Directions describe each function. So you're just telling me, well, g7 of f of x is a, well, let me go look at my stuff up here. If it's outside, it's vertical. So, okay, I know it's vertical something. Vertical. Well, let's go see. 7 is greater than 1, so it's a vertical stretch. Okay, that's all I want you to do on those ones. Then this is a star practice question. Try your best on that, but it is multiple choice. And again, you have another multiple choice. And remember, who is your best friend? Desmos. All right, I will see you guys next week for Unit 9.